this series of videos, we will be looking at topics in Algebra 1. In this lesson, we will be focusing on variable substitution.
All right, hi everybody. So now we're going to take a look at evaluating expressions. Specifically, really what we're looking at here is substitution, variable substitution. Now, granted, when we talk about evaluating expressions, usually our goal here is to get a single value at the end. In a couple of these, though, that won't be the case. But I do have a point behind doing this here. I want to make sure that everybody is comfortable with this idea of variable substitution. So, for example, in question 1 here, I've got a divided by 2 plus b. And then what we're going to do is we're going to assign a value to a, we're going to assign a value to b, and then evaluate this expression. Okay? Now, that should be pretty straightforward. It really should. However, I've seen in a lot of cases, even at the high school level, where as soon as we start to assign values like this, it becomes unclear what exactly is meant by a equals 4. So in this case right here, notice that what we're doing to a is we're dividing it by 2, and then we're adding b. Okay, without knowing specifically what those numbers are, that is the pattern here. Whatever the value of a is, divide by 2, and then add b. Now, please, this is not what I mean. Okay, this is not what I mean. I don't mean put a 4 behind a and then put in essence a 1 behind b. That's not what I'm talking about, okay? But I see this happen a lot, okay, where for some reason or other this idea of a equals 4, there's still this idea that a has to stay in the expression, and I'm just inserting a 4 in there with it. But that's not what I'm referring to. Okay, once again, we got to look at what the expression is telling us to do. We take the value of a, divide that by 2, and then we add b. Well, the value of a is 4. I'm going to divide that by 2, and then I'm going to add the value of b. Okay? And then I'm going to make sure I follow order of operations. I'm going to do the division first. 4 divided by 2 is 2 plus 1. And so my answer is going to be ultimately 3 when you plug in those particular values. Okay? So we're just going to do a handful of examples here. And this one over here, what am I doing? What is the expression telling me to do? Well, it's telling me to take the value that is assigned to x. I'm going to subtract 5 from it, and then I'm going to subtract y. Okay? Now, I've purposely chosen a couple of values here, one value in particular, to make a point about how this works here. So the value of x less 5, and then less whatever that value of y is. Okay, so 10, this is going to equal 10 minus 5, and then I'm going to subtract, and I know this really hasn't come up much in these particular lessons here, but we might as well discuss this. I'm going to subtract a negative value here. It would be very easy to assume that those two negatives are the same negative and just pass on right by it and just think that means minus 4, but actually it doesn't. I'm subtracting the negative 4 here. Now, my goal over the next few lessons will be to take a look at how that sort of thing works. We'll explore that in a little bit more detail. But for now, that's worth a little look at here. So 10 minus 5 is going to be 5. Subtracting a negative, and I should have put brackets around the 10 here. Subtracting a negative, okay, if you've just memorized kind of the procedure here, it means adding a positive. So that's just going to be 5 plus 4. And so our answer is 9. Okay, let's keep going. A multiplied by b plus c. Okay, so a, the value of a is multiplied by the sum of b plus c. Now, the value of a is 6. The value of b is 2. The value of c is 3. I have to do what's inside the parentheses first. So 2 plus 3 is 5. I'm going to keep it in parentheses because that's going to keep it separate from the 6 and I won't get confused. And then 6 times 5 is 30. All right, now this question could have been done a different way as well, because what we could have done here, and I'll just put a little line here, we could have distributed that value of a through, because I'm multiplying a by the sum of b plus c. Multiplication distributes over addition. So this could have been written as ab, okay, a multiplied by b plus a multiplied by c. And now when I substitute those values in, I'm going to get, this is a multiplied by b, so 6 multiplied by 2, plus, again, 6 multiplied by 3. And 6 multiplied by 2 is 12. 6 multiplied by 3 is 18. And again, when you add those together, you get 30, and as you should. Okay? Because I'm really doing the, although I'm approaching this a little bit differently, it is still the same expression, and these are equal. Okay, equal to each other, so the result should be equal when I plug in the values of those variables. Good. Now here, I like this one. I'm going to do this one in two different ways here, because our goal here is to evaluate. We want to get you guys really comfortable with how these things behave, how numbers behave, and then therefore how letters behave. So I'm taking x and I'm adding to it the value of y, and I'm adding it to, again, the value of y. So that's going to be 7 is the value of x, plus 8 the value of y, plus 8 the value of y. Now, I've got a 7 plus 2 8s. Okay, so that's really a 7 plus 16, and 7 plus 16 is going to be 23. So there's my answer. Or, what I could have done was this. Even before I did the substitution, I could have noticed, well, I've got 2 y's there. You know, it doesn't even matter what the value of y is. Because there are 2 of them, I can just double it by multiplying that value of y by 2. Now, I'm taking, what this is telling me is that I take the value of x and I add twice the value of y. So that's going to be 7 plus 2 times the value of y, which is 8. So it's going to be 7 plus 16, and once again we get 23. So you might be able to see at this point here how maybe it's useful, maybe that's a good idea to simplify algebraically first before I do that substitution. Now we're going to take a look at some other issues that might pop up. All right, now here for this one, I'm multiplying A by the product of B and C. Now, I want to be clear about how this one differs from one of the previous questions that we did. When I make my substitution, this is going to be 2 multiplied by the product of B and C, which will be 4 multiplied by 3. Now, I need to do what's inside the parentheses first, so 4 times 3 is going to be 12. And then I'll multiply 2 by 12 to get 24. Now, to be honest here, because this is all multiplication, order doesn't really matter. I could have done that in any order I would have liked there, and that would have been fine. What I do want to note here is that what you cannot do, okay, this is not equal to A, B, A, C, as I sometimes see people do. Please, please don't do this. Multiplication does not distribute over multiplication. This is not true. Okay, so if you're tempted at all to do that, please remember how this works. Multiplication distributes over addition. Okay, exponentiation distributes over multiplication, and we'll see a couple of examples of that in just a second. So the answer here is 24, not whatever that turns out to be. Another issue that pops up here, notice I've got x multiplied by y squared. X is going to be 3, y is going to be 5. So when I make that substitution, and I'm going to put these in parentheses here, and this time this is important, really important. Okay, 3 multiplied by 5 squared. It's important that you catch or remember that in order of operations that squaring comes first. Okay, so this is going to be 5 squared multiplied by 3. You cannot multiply the 3 by the 5 and then square it. Please, once again, please don't do that. Okay, you cannot do multiplication prior to that square. So you can't make that 15 squared. This has got to be 3 multiplied by 25. Do the square first, and then I multiply and I get 75. That's the correct answer. Over here, okay, x plus y squared. Now there's addition here. Squaring does not distribute over addition. Okay, when I do the substitution, make x equal to 3, make y equal to 4. Okay, 3 plus 4 is 7. 7 squared is going to be 49. Okay, that is the correct answer. Please do not do this. Do not turn that into x squared plus y squared. Exponentiation does not distribute over addition. And just to show that those aren't the same here, if I made that 3 squared, that would be 9. and 4 squared is going to be 16. The sum of that is 25, and that is not what this is saying. Okay, they are not the same. 49 is the correct answer. You need to do what's inside the parentheses first. Okay. Now, I'm not throwing these examples out here of what not to do to confuse you here. I'm trying to address very, very common mistakes that get made here, and hopefully if you're the sort of person, if you recognize, oh yeah, I do that this will be another one of those things to kind of reinforce to you the proper way to apply the order of operations there. So here's an example of what I was talking about a few minutes ago. Okay, this is squaring over multiplication. So I'm going to substitute the values in. 4 multiplied by 5, and that's going to be squared. So A and B get replaced with 4 and 5 here. Now I do what's inside the parentheses first here. 4 times 5 is 20. Squared is going to get me 400. Now in this case, there's another way you could have done this, or I could have made that A squared B squared. Now, before you look at me and say, yeah, but you just said I couldn't do that. You can't do it over addition or subtraction, but you can do it over multiplication. That's okay. Exponentiation distributes over multiplication. And it should make sense, okay? Multiplication distributes over addition because multiplication is a fast form of addition. There are related ideas here. This is just kind of a level up in terms of the operation. Exponentiation is sped up multiplication. Okay, so this is just a faster way of doing what's going on right there. So they are related here, and that's why it works here. But exponentiation is too far removed from addition to be able to distribute it across. Now here, when I make the substitution, this becomes 4 squared multiplied by 5 squared. And remember, I have to do the exponents before I do the multiplication. So 4 squared is 16, 5 squared is 25. And again, when you multiply those together, you'll get 200. Now, here, for these last two, this isn't so much about evaluating it as it is just addressing another little issue that comes up when you do substitution. My expression here is 3 multiplied by x plus y. And now I've told you that x is equal to 2 plus a. It's now no longer a single number. It's this binomial, okay, these two values together. And y is also these two values together. But look what's happening in the expression. 3 is being multiplied by whatever x is. Well, x is this. Now, here's the mistake that gets made. 3 multiplied by 2 plus a. Okay, and then you're going to add a minus 1. There is a mistake here. And the mistake is this. The expression says that 3 is multiplied by x. Well, x is 2 plus a. Okay, x is this whole thing here. But here, the only thing getting multiplied is the 3 by the 2. 3 is not being multiplied by the a. So 3 is not actually being multiplied by x here. It's being multiplied by a part of x. In order to make that work, you have to put parentheses around whatever x is being replaced with. And actually, you'd be smart to do it around the y value too here. Now, multiplication distributes over addition. So 3 times 2 will be 6. And then I'll get 3 times a. And then I can add a minus 1. And there's no coefficient in front there, so I can just leave it like that. And putting this together, I've got 3 a's here and 1 a here for a total of 4 a's. And then I've got a 6 minus a 1, so 4a plus 5. That's the value, or the expression now that we're looking for. Finally, a very, very similar sort of thing here. Well, this is going to be a little bit more complicated, and so kind of depending on the level you're at here, this might seem a little more advanced than a lot of what we're doing here, but trying to tailor this to a wide unknown audience here. A is x plus 2, and b is 4 here. A is being squared, so this is going to be x plus 2 squared. But again, if you don't put parentheses around the x plus 2, then you're not squaring all of a, whatever a represents. I'm only squaring the 2 here. that square only applies to the thing that's immediately in front of it. So if I wanted to apply to more than just that 2, I need to put parentheses there. And then b is going to be replaced with 4. And now, kind of depending on where you're at in terms of your math here, you would know that this is x plus 2, x plus 2. And so this will become x squared plus 2x plus 2x plus 4 minus 4. And where I'm getting all this is just by distribution. Okay? Because both x and 2 here are being multiplied by the x and the x distributes to both, the 2 distributes to both. And that's where I'm getting this. X times x is x squared, x times 2 is 2x. 2 times x is 2x, 2 times 2 is 4. And now just cleaning it up, I've got an x squared term. 2x is here, 2x is here for a total of 4x's, and 4 minus 4 is 0. So that I don't have to write that because it's just 0. So anyway, I hope that gives you a little bit more of an idea of how substitution works. I hope that if you've seen anything in here, any of these kind of mistakes in thinking, little errors that we make, that and you recognize that in yourself here, that this will give you at least something to think about, and hopefully will try to help you avoid making those mistakes in the future.